Hello members, welcome to this lecture again. In this discussion, we are going to look at timers in PLCs, and we shall be able to design a simple circuit to demonstrate the working of a timer in PLCs. So we have to understand that timers become a necessary evil in most cases when you want to design sequential circuits. Circuits that are going to be repetitive, that are going to operate maybe throughout a day, 24 hours. Remember, this is done in automation, of course, to minimize human intervention. So you need timers to count or to switch on or to energize a particular circuit and have a particular event take place when it is desired to be energized, and then be de-energized when it is desired. With the help of timers and counters, you are able to design such. A simple one could be for example, when you're designing a starter motor, um, I mean a starter for motor starting. So a starter like a start delta, you can do it by allowing a delay when the motor switches from star to delta, and then that kind of delay can be done or can be achieved by use of a timer. So, and one of the timers that we know uh, available is the on-time delay timer. We have also what we call the off-time delay timers. Then we have retentive and so many and so forth. So in this video, we are going to look at how we can do an on-time delay timer that is going to run PLC using ladder logic. So let us rename a new project. Remember, we have already opened our TIA portal version 17 for Siemens PLCs, and let us call it our timers. So once you're here, you are just going to add a new device. So the new device you're going to add is a CPU, and we are going to choose any of these CPUs. So once you've checked on what is available, remember whatever you choose should be above 4. So 4.5 is good for us. So this is our CPU. I can enlarge so that you can see properly. It has the input and output side. So it receives digital inputs and digital outputs. So if you wanted to add on modules, you would just add on modules whichever way you want. But with this simple circuit that we intend to design, this is very sufficient. So what you have to remember is to do some settings. Let's first check on our program. We go to protection, make sure that for you to have the simulation go on, make sure this one is unselected. So we go, and then let's go to properties and go general. So here we shall come here and unselect the protect confidential PLC configuration, and we give it a full access so that any other person can do the configuration without password. So what we do, we go to, we have finished configuring our CPU, so we go to creating a ladder logic program that is going to have the components that includes a timer. So let's click on that on program block and add and click on main. So here we just put our normally open contact that we are going to use to mimic the operation of a push button. Then we have a coil to represent our output. I want it to come here, so let's take it here. Then we come to instructions here and pick timer operations. So under timer operations, let us pick an on-time delay, on delay timer. So on-time delay timer. So we are going to change its name. We can give it timer, maybe 1. Then what we are also going to do, we are going to create some PLC tags. So let us show all tags. We are going to put a push button, and the data type it is going to use is a Boolean. So let's leave it at that. Here we add our output, which we are going to call a motor, and let that output have the address of an output. So Siemens uses Q, and this is supposed to be Q0. So the input is I, and the output is Q. What else? I think this is enough. So what we can do is to come back to our main and then make sure that we put in those tags. So this is a push button. We come here, we said this is going to be a motor. Then we said, now here, that is the preset time. The preset time is now how much time do you want the motor to switch on after a delay. So we are going to make it 5 seconds, but to type in on the figures, we shall make it 1,000, 5,000 milliseconds. So that would make it 5 seconds. So we come here and put our timer, we shall call it timer 1. So if it becomes like this, we rename. So if that error remains, we go and define the tag and make sure that the data type is time. So what we do is that we see that now our timer is ready for simulation. Let's go to download program to the CPU and have it run. So we have to let it download. So if it doesn't, what we do, we run a simulation. So once we run a simulation, it is going to start configuring, and then later on loads the configurations, and then we'll have it ready. So here you click start and let it load. So consider as trusted, and then let it do the compilation of the configuration. So once it has done, you say load and let it load the configuration. So here you click no action. On no action, you have a draw down arrow. Just click there and go to start. You finish. So once we are done there, what we are going to do, let's just check something simple here. Let's go to device configuration and I show you some. So you can see among the digital inputs we have is a push button, and among the output we have a what? We have a motor. So what we are putting in the push button, it is receiving either a 1 or a 0, and then when this one receives a 1, it is on. When it receives a 0, it is off. So the other timer is saved on the address of the memory. So that's why we see it. So now we go back to our main. We now have to find a way of simulating this. So what we are going to do is to create a force table. So under force table, we shall know we have our push button, and that one is already there. Then here the output that we have is a motor. So that one is done. So we bring it down here and come here on the main. I check here on monitoring on and off. I click it. So I want to start the simulation, but before that I must make sure that power is reaching my power rail and the RAM. So I'm going to come here to my simulation table. Okay, which I have used a force table. I make that one false. So if the push button is a false, then that means the output is going to be false. But when that, okay, let's first run and see. So you see we have no output. So let's make it a 1 so that it is high. what happens is that when we force output, that when you force that input, you see the counter, I mean the timer starts to count. Uh, but of course, when 5 seconds elapse, that's when this motor is going to receive power. So basically, that is how you can design a timer and simulate it in PLC. We start again. Let's put 0. After putting a 0, we come here. We force that 0. It is going to be off. Come back. We force a 1. Okay, when we force a 1, it is going to start counting. It is going to start counting. And when 5 seconds elapse, you have the motor. Ladies and gentlemen, this is how we can simulate a time on a PLC. To have the going on of a particular device, can be lamps, it can be a motor, be delayed by a particular amount of time in terms of seconds. Thank you.